Greetings, students. This is Irvin Howard again. Welcome again to EMH Math Portal. My name is Irvin M. Howard. I'm serving as your EMH Math Portal online math tutor. Today we're going to look at negative exponent rule. And this rule is very simple. Any raised negative exponent will equate or equal to an expression raised to a negative exponent, which is equal to 1 divided by the expression with the sign of the exponent change. Meaning that any negative exponent, any raised negative exponent you have in this case will be rendered positive as the reciprocal of that number. Let me give you a few examples. For instance, 5 raised to the negative 2 power. Okay, now when you have this problem, you apply the formula because it fits the criteria of the formula when you have raised negatives. In this case, you have the base is 5 and you have a negative 2 integer. And then what we're going to do is equate that. This becomes 1 over 5 squared. And notice that the square has become positive. It's changed, all right? You've changed the negative to a positive with the exception of this number becoming a reciprocal of that number, all right? And then you would just simplify it. This would be 1 over 25, all right? Let's try another one. Let's try something different with the combination of coefficient and variables. You have 7a raised to the power of 4. And years of teaching math, especially with this subject, students tend to assume that you raise the negative 4 with the 7, but in this case it's not, because these are two separate entities. You have a coefficient of 7 and then you have the raised power, which is negative 4 to the base of a. I tell my students, you know, if you have to just imagine that you're separating the variables and a coefficient, and you see that the raised negative belongs to this base. So what we want to do is keep all your negative exponents closely identified with its base. So negative 4 is not part of the base for 7 in this case. All right. So that would be the raised problem, or that would be the raised base. So we have only applied this formula here. So what we're going to do is we're going to use the type of multiplication, because this is similar to multiplication. 7 times, all right, and then we apply the formula 1 over a to the 4th, all right, and then that equals to 7 over a to the 4th. Notice that 7 is a whole number, and we kind of perform a little multiplication, because when you have when you have variables and coefficients, or coefficient with variables, it's a form of multiplication anyway. So hopefully in the series with the polynomial series, I'll give you more explanation about that. So in any case, this is 7 over a raised to the power of 4. All right, any questions? I'll try to set my block so that if you have any questions, you can post them as soon as I get my math block all together. All right, let's try one more. Okay, we're going to have 1 over c raised to the power of 4. Now, this time we have the negative, we have c raised to negative 4, which is in the denominator. Notice that all of these are like whole number positions, or numerator positions, right? And then this becomes the denominator, and this also becomes in the denominator. But this time the problem starts off with c raised to the negative power in the denominator. So there's going to be a change. So I tell my students, whatever negative exponents with bases with negative exponents, whichever position in the numerator and the denominator, it's going to reverse. They're going to change position, with the exception that the changed number in either case may render the exponent positive. There may be certain cases where it becomes negative, but we'll look at that when we solve additional problems in the properties of exponent series. Okay, in any case, what we want to do is we want to treat this. All right, let's write this in a form of division because that's what it is. It's actually a division problem. All right, when we look at fractions. So we're going to say 1 divided by c raised to negative 4. And in this position, c has become somewhat like a whole number now, because we have division, all right? Because this is something that you all can associate, and it's very familiar, all right? And then at the same time, we can go ahead and we can render this using the formula, render this positive, all right? This is 1 over, first mistake of the series. 1 divided by, change this into its negative exponent form using the negative exponent rule. Change this into its proper form. So that would be 1 over c to the 4th. All right, but yet we're not finished because this is a whole operation of division operation, and you know from experience that when you have a division problem, divide by now a fraction, what happens? This inverts, or you find a reciprocal of this because of the division sign, and then you would change the sign from division to multiplication. And let's go ahead and do that. So we have 1. Okay, let's change this. I'll go ahead and change it to multiplication. All right, and then we go ahead and invert it. C raised to the power 4 over 1. Okay, and then this becomes c to the 4th power. All right, just put that in the position. All right, but if you have any questions, please save it until my math blog is established, and I'll be glad to try to answer any questions dealing with any of the movie videos. Probably will make some retracts if I need to. I'll be glad to do that. But it's important that you understand the whole steps. So far, I've created 4 videos with the Exponent series. Please look at each one in the sequential order so that you can get a better understanding when we start to solve exponential expressions that will combine several properties that you should already know. Okay. All right. This is Irvin M. Howard. Thank you for joining me again at EMH Math Portal as the presenter and online tutor for the Exponent series. Again, have a good day. Life is worth living.